Hello everyone, Dr. Vaughn. We're going to continue on now with Chapter 10, Part 1, and this is problem number 2. So here we have a data table, and if we look at that really quick, we have two different categories, technology and financial institutions. I'm going to load this into Excel so we can use some of the functions in Excel to do our analysis. All right, so while this is loading, we'll enable editing. There it goes. Hopefully it opens. So while we're waiting for that to kind of fully load and hopefully it comes through, if not, we'll have to create our own Excel spreadsheet instead of using the auto import feature here. But let's take a look at this. So assuming the population variances are equal, and then we have two groups. We have two groups of data, and population variances are equal. And then is there evidence that the mean average, brand value is different? So these things, mean tells me I'm comparing means, different tells me I'm doing a two-tailed test, and then I have these two groups, and we're comparing the mean between these two groups. So it's those things together with this population variances are equal that tell me that I'm going to be using this independent samples t-test, and this time, unlike question 1, we're going to do a two-tailed test. So again, we're going to use this same kind of the population standard deviations are unknown, but were assumed equal. It tells us that they're assumed, the variances are assumed equal. And so we're going to use this pooled variance and again the T statistic formula, much like we did in question 1. So we'll start over here by looking at the hypothesis. This time we're doing a two-tailed test, so we can kind of ignore B and D. We're doing the equals and not equals case. And remember, the equal side always goes with the null. So we're looking at mu1 equals mu2 as being the null hypothesis, and that the means are different as the alternative hypothesis. This would be choice C. All right, now we're going to find that T statistic. Now I do need to see if my Excel sheet has loaded here. I'll pause the video for just one moment. All right, we're going to continue on. That other Excel sheet wouldn't open up, so I actually retyped the data into a new Excel sheet. I also inserted a blank column over here just so I could have some room to write some labels in. So we have these two different sets of data, technology, financial institutions, and we're trying to compute T-stat. So look back over at the PowerPoint slide. We again need to compute the pooled variance, but in order to compute the pooled variance, I need the sample sizes and I need the standard deviations. These are the sample standard deviations. So we're going to put on here the count. This is going to be the N. And for each set of data, we'll just, make Excel count these for us, although it's not too terribly hard to count them by hand. This is how many data items we have, which is 8. And then I should be able to just drag this over to do the same count feature coming down over here. And then we need to get the sample standard deviations. So remember, the sample standard deviation equals stdev.s, and we'll click and drag to find the sample standard deviations. And then once again, I should be able to just drag this over and use the autofill to get the other sample standard deviation. All right, so now we're ready to find the pooled variance. And so we're going to be following this formula here, just like we did in the last video. So we'll do equals, parentheses for the numerator. And we'll do another parentheses, n1 minus 1, close parentheses, times sample standard deviation, quantity squared, and then plus, and now we'll do another parentheses, b2, the n2 minus 1, close parentheses, times this sample standard deviation, quantity squared, and let's see, it looks like I did a times here instead of an exponent, so we'll fix that. And that should be the entire numerator. So now I'll do divided by, and in the denominator, we'll do parentheses, do n1 minus 1 plus n2 minus 1, close parentheses. You could also do n1 plus n2 minus 2. And in this case, it's 2n1 because they're both equal to each other. n1 equals n2, so it's 2 times 8 minus 2, or 16, which is actually going to be divided by 14. So anyway you want to do this, that's our pooled variance. And now we're going to find our T-stat, the test statistic. and we'll follow the formula again. So in the numerator, once again, we have the difference between the sample means. So I need to compute the sample means. I haven't actually put those in here yet. So let's put that here. We'll do equals average. And we'll drag that over. Okay, so now we're going to do equals the sample mean 1. I'll put this in parentheses for the numerator. Sample mean 1 minus sample mean 2. That's the numerator. Once again, this mu1 minus mu2 is 0. Where the null hypothesis is these two means are equal to each other. So mu1 minus mu2 would equal 0 if they're equal to each other. And now I'm going to divide by the square root of, now I need to do the pooled variance, which is here in cell B14, times parentheses 1 divided by n1 plus 1 divided by n2. And Excel should know the order of operations there. Close parentheses for the square root, and I'm sorry, for the sum, and then close parentheses for the square root, and that should be everything. All right, so here's our t-stat, negative 5.182, and we want to report this again to 2 decimal places. So negative 5.18, round that one in my head. All right, now we're ready to find the p-value. Just like last time, the p-value is the t-distribution. However, this time we want to compute the two-tailed t-distribution to find out how much is outside of this value of minus 5.18 or plus 5.18. So we'll do equals t.dist.2t, and we'll put in our t-stat into the first spot, and in the second spot, the degrees of freedom, if you remember from the slide, is n1 plus n2 minus 2. You could count this. 8 plus 8 is 16 minus 2 gives you 14, or you could program it with just kind of the cells B11 plus C11 minus 2, close parentheses. All right, now, oh, it gave us an error. Let's see what happened here. Okay, I think I figured out what the error is here. We need to have the positive t-value to do this t.dist.2t. So what I'm going to do instead is just use the one-tailed t-distribution to find out the probability of it being below negative 5.18, but then I'm going to multiply by 2 to double this, because the probability below negative 5.18 times 2 would be the probability above positive 5.18. So I'll just do this 2 times and then use the one-tailed t-distribution because I have the negative t-value in here. I think that this should... Oh, yeah. Now since I'm using the regular t-distribution, I have to put the true value in here. All right, so 0.00013. And again, to the third decimal place, this is still going to round to 0.000, but it's a little closer than the last one. All right, and finally, we're going to make a rejection decision. So the p-value is lower than our alpha value, 0.1. We're at an alpha value of 0.1. Our p-value is below that. Our p-value is low, so we reject the null hypothesis. So it's either A or C, reject the null hypothesis. And when you do reject the null hypothesis, there is evidence that there's a difference. So I think the correct choice here is C. All right. And let's see, now we're going to repeat all of this, assuming that the population variances are not equal. I'm going to stop this video, and we'll probably pick up with this in a second video. I just don't want this to get too long. See you soon.